Hello, calculus fans. Okay, so let's try this problem. We're going to talk about an oil storage tank, and it ruptures at time equals 0, and it starts leaking oil. And what we're given is the rate of the oil leak. So we'll know that it leaks oil at the rate of 80 e to the minus 0.05 t liters per minute. And what we want to know is how much oil leaks out in the first hour after it ruptures. Now this is the leak rate. It tells us that at any particular time, how fast is the oil coming out of the tank, measured in liters per minute. Now in Calculus 1, we have a net change theorem, and it tells us that if we want to compute a total amount from a rate, we have to compute an integral. Now in this case, we want to know the total amount that leaks out in 1 hour, so we'll integrate from t equals 0 to t equals 60, and that's because the rate is measured in minutes. We want to know how much total comes out in 1 hour. That's from 0 minutes to 60 minutes. So what we'll do is we'll say that our total leaked oil is the integral from 0 to 60 of 80 e to the minus 0.05 t dt. We're just going to integrate the leak rate, and we're going to do that from 0 to 60. Okay, so now we'll make a substitution. So we're going to take this integral and we'll substitute for the inside function. In this case, that's the exponent, that minus 0.05 t. So du equals negative 0.05 dt. We don't have a negative 0.05 dt, we just have the dt. So we'll multiply both sides by negative 20. That gets rid of the negative 0.05 on the dt. So we have negative 20 du is equal to dt. Now we're making a substitution on a definite integral. That means we must change limits of integration. When we plug in 0 into this, plug 0 in for t, we'll get u equals 0. We'll also plug in 60. And if we plug in 60, we'll get negative 3. So we're plugging in 0 and we're plugging in 60 into this to get new values for u. Alright, so now we're going to take our total leaked oil amount. This is our integral, and we'll substitute, and we change everything into our new limits of integration, our new variable. Everything is changed. The dt turned into negative 20 du, and the negative 0.05 dt, the negative 0.05 t turns into u. When we clean this up, we'll just move the multiplicative constants out in front, so that's the negative 1600. That's the 80 times negative 20. Now we have an easy integral. To evaluate this, all we need is to write down its antiderivative. That's easy. We'll just get e to the u. Notice we're not going back to the original variable of t. It doesn't happen with definite integrals. It never happens. And just plug everything in. Upper limit minus lower limit. E to the 0 is just 1, so that's why we have e to the negative 3 minus 1. And this is measured in liters. And I'm going to leave things like this because this is the exact value. If you needed to compute an approximation, no problem. You could take this and put it into your calculator. But that's not what we were after here. We were after an exact value. So this is our final answer. Okay, that's all for now.